So, first of all, welcome to the Eviation Alice. This is the world's first all-electric commuter aircraft, if you will. The aircraft's been built from the ground up to be electric. It's not a renovation of anything. This is why it doesn't look like anything you might have seen before. But I think sitting here, you can understand that at the heart of the design process was, first of all, the end customer experience, the passenger experience. It's a bigger cabin than what you would expect in a turboprop or in let's say a kind of regional commuter as it's used today. Still a 9-seater plus 2 crews, so could be operated by local operators, like what's called in the US the Part 135 operators, operating on demand or operating scheduled, of course. And this is where we start, but everything around it is actually all the technology of the electric propulsion. So, for lack of a better joke, internally we say it's a huge battery with some plane painted on it, and which is pretty much true. The maximum takeoff weight of this plane is 14,000 pounds, but out of it 8,200 pounds are battery. So this ratio, this huge battery integrated into this plane, actually 920 kilowatt hour usable, is the heart of what makes it possible to build a plane like this. And then, of course, if you've built it this way, you need everything else to be very light. So the plane is all composite. The propulsion system is very unique. You'll probably notice that we have wingtip propellers and a tail propeller. And the wing is very, very slim, and the design is very, very slick. No inlets, no cooling drag, if you will. And the reason is really just to hit the numbers. So we have to be extremely efficient at cruise, and we have to be very, very slick by design, and electric propulsion allows us to do this. In the company, we have a slightly broader view of the word. I think sustainability has been thrown around a lot, and usually people immediately say, okay, sustainability, zero emissions. Well, that's not enough. Sustainability, I think, really goes 3 ways. It's, first of all, a product needs to be economically sustainable, because if you've built something great that doesn't pollute, that's nice. But if it doesn't make economic sense, especially for commercial aviation, it's just not going to happen. And I think this is why this aircraft is so compelling. The Eviation Alice is going to cost roughly $200 to operate per flight hour. That's a ridiculous number for a plane that size and this performance. And this is actually better than anything else out there today. So it's, first of all, economically sustainable. This will survive the test of the market. Secondly, yes, environmentally sustainable. That's hugely important, but it's not only emissions. It's energy efficiency, how much energy you're actually spending. Electrical systems emit very little heat compared to, well, reciprocating engines. And that's why it's more efficient to use them in order to fly people around. Then, of course, zero emissions. Then, of course, noise. I want this to be a less noisy aircraft. Why? Because the footprint that you have on the environment is not just how much CO2 you've emitted. And noise, I think, actually takes us to the third aspect of sustainability. It needs to be socially sustainable. And I think that means if you have a landing strip that's close to a populated area, and today it closes at 4 p.m. because no one wants to hear those planes take off and come back and whatnot. It will be nicer. I mean, again, if you're a pilot and you live next to that airstrip, well, that's great, right? You have somewhere to fly from. But today you don't really like to have that house not far from the airstrip. I think this should change, because planes need to be quiet and they need to give a service, a true point-to-point service. The cockpit only has one throttle. The pilot does not choose how much power he gets from each propeller. There is a fly-by-wire system and a flight control computer that does that. The same goes for emergency situations. In a cutoff, the system will know way before the pilot that there is a thrust loss in one of the wingtips, be it because of a malfunction or because of some mechanical trauma, let's call it. You met a flock of pelicans. And in such an unfortunate and very rare event, what will actually happen is that the system will cut off the other wingtip to not have that asymmetry. and the plane can continue safely to cruise and land with its tail motor alone. Now actually it's not just to cruise and land, we can continue takeoff. In a takeoff situation, even if you're after V2 and you can't brake anymore, and then you've lost the wingtip, the plane can continue takeoff, have a positive rate of climb, go around and land safely. So this plane has been, let's say, excessively built to have that redundancy. One of the reasons is that we believe this plane could, should, and will be safer than anything else out there today.